Everybody. Last meeting of the year. Who is here for the first time? You've been before, right? Okay. If you want to receive this the meeting notification, please sign up to our website. There's if you go to SFCDUG.com.org. You will have there's a field to input your email, and you can get the auto notification. As usual, follow us on Twitter, Facebook, LinkedIn. We are starting to fill all the spots for next year, and we have really amazing presenters. And if you want to present, just email us. SFDUGcoordinator@gmail. Just a few announcements before we get started with our awesome presentations. Everyone online is muted, but if you have questions, please write them down in the chat panel. And from time to time, we're going to do our best to read them to the audience and the speakers. So be patient while we get to those questions. We have a new committee member. Her name is Lauren Wixon. Is she here?
No, she's in Utah skiing.
Oh, she's skiing.
Yeah.
Lauren has a background in marketing, and he's going to help Jennifer in our effort to expand the word of the group and reach out to new speakers. So welcome, Lauren. We'll do another formal introduction next time when she's here in person. We have two speakers today. Anthony Hauck is on the line. Anthony and Ian Keough were scheduled to present together. Ian Keough sent us his apologies. He is actually attending a concert. But Anthony is going to speak on his behalf and present the recent innovative work he's doing with HYPAR, the latest venture after they move out of the Dynamo team. Welcome, Anthony. I'll let you introduce yourself in a bit. After Anthony's presentation, we'll have Andrea Zani. He's also our newest member. I don't know if you met him before. He's part of SFDUG as well. And he has a great topic as well related to computational design and sustainability analysis. And our meeting is in HOK just because the AIA San Francisco is really busy on December. But next year, we are probably going to do a mix of either lunch presentations and evening presentations. They're sorting out how available the AIA San Francisco is, and if you want your organization to host these meetings, just let us know. We could move and present as long as it's accessible for most people. I know in the past we've gone to SOM, Guilty Bagger, Gensler here, but by default, if the AIA is not available, please let us know if you want to host it. Plus, it's a good way to expose your own users about this conference. Why don't you talk about it?
Okay. Yeah, we are moving to a non-profit organization in order to actually receive funds to finance three things. So finance a better lecture, so to be able to host good speakers from all over the world. Another topic is actually be able to give a workshop and a lesson in programming skills related to Dynamo and Grasshopper, but also Unity, so with C#, JavaScript, and Python. And the third topic is also to create a research body like OpenAI to do research in artificial intelligence and application for the AC. So this is our topic for the next year. And we are currently collaborate with some organization to make this possible. So it's going to come soon.
Yeah. So if the whole thing, by giving us a legal framework, we have the ability to do more things and offer more activities in the community. So stay tuned for. We're hiring.
Yeah, and of course, everyone is more than welcome to join us at the beginning of this journey. So we are right now. We just have Andrea Zani with us, Lauren Wixon. So everyone, we have spot available. So we are looking for great collaborators and people that are enthusiastic as well to participate in this community research effort. Yeah, so last month there was Autodesk University, and now they are all available, the recordings. So feel free to look at that. It was a great environment. I think some of us was there, presume like half of people here. And yeah, we're really looking forward to see you guys there next year. And also, if you have a topic to present, it can be a great opportunity to meet other people and try to expand as well. Yeah, we had 3 presenters also from this group, so we're really proud of this achievement.
And let's congratulate Alberto because he got married after after Autodesk University.
Yeah.
Here? No?
Not yet. And yeah, my wife also allowed to bring here augmented reality bottles, so you can drink the wine and then you can see the specific experience that came out with those models.
You showed it at the end, right?
Yeah.
I worked it. This is West Coast, the first edition of the Core Studio Hackathon on West Coast. It's going to be in Seattle next year in March. Because it's so close home, it might be worth to consider if you want to attend. I think they are taking teams as we speak. So I think it's one. Forza Massetti's hackathon is the industry level type of event, and it's all well worth it if you have the chance and the ability to attend. We might send a few of us from HOK, and check their website. And if you want to team with some of us, just let us know. The idea is that this is not company based; it's just community based.
And also the last link that you can see is the winner of this year. They have done interesting project. Probably they're coming up also here to present, like Grasshopper, so a web integration with Grasshopper as well. So it's pretty interesting to see what the guys developed. Also from Reno, from Autodesk, they came there and helped people. They have done also a really interesting workshop about machine learning the previous day. So they offer also this opportunity with Grasshopper.
Just a new product announcement. There's a Reno CFD that just launched maybe a month ago. It's a much more affordable way of doing CFD computational analysis than Autodesk version, and it's version 2.0, and it's free. So just look for. You can Google it or just look for it at Food for Rhino if you're interested in those type of analytical things. And then we're working the logistics to offer our first workshop in 2019.
Yeah, so there is this interesting topic to work with also Danny Bentley from SOM to actually offer this opportunity for working directly in Dynamo with Python and then send the geometry in Unity and visualize this geometry in augmented reality. So we would like to provide this framework for this workshop and offer to the community. And it's going to be available probably in 2019. And we're going to collaborate with Designmorphin. They are also a really great, say, community or organization that offer this workshop. Maybe some of you know also Autodesk will help in that as well.
So stay tuned. It's not going to be free, obviously, because we need to actually take care of the speakers and presenters. And obviously with Designmorphin, if you haven't heard of them, they're big in Europe, putting together high quality tech workshops. And this is going to be the first time they offer something on the West Coast. I think they've done something in New York.
Yeah.
Nothing in this coast. So it'd be great to have that partnership ongoing and offer high quality training. It's going to coincide with our consolidation of the nonprofit, and so that's going to be our first opportunity to raise some funds and bring more people. Next meeting is January 18 at the AIA. This is going to be a lunch edition. Actually, I think we're going to feature parties, right? You're going to speak. I think she's going to give us a summary of her work at AU.
Okay.
You were the winner, right? You was the winner of the Dynamo Dynamo competition that happened there, right?
Yeah. So Dynamo Design Slam. There are 3 design slams. One for I think improv works, one Dynamo, and one is for Fusion 360.
Yeah.
And it's a live on stage competition in 20 minutes to design something. Every year they have a theme, and it's fun.
Yeah, and this year you won.
Yes.
So really happy about that.
Awesome.
And
love to hear about that, and we'll do a summary of some of the Dynamo things we learned there. And then what's the other speaker?
yeah, stay tuned about that.
Thank our sponsors. The food is Imagine It. Next year, ID8 was incorporated to Imagine It, so Imagine It is now our official sponsor. And the wine you see there is a courtesy of Tactics Studio. Gensler for the communication technology, AIA San Francisco for their place, and obviously HOK for this spot as well. So with that say, any questions? And I want to pass the controls to Anthony.
Yeah, we're really honored to have these 2 speakers here today. I mean, Ian is not available, but Anthony also before he created Project Fractal, if you may know, and Ian is the father of Dynamo. So when you open Dynamo, there's always his name. So it's a big pleasure for us to host them, and it's a good opportunity to start the new year also as well. Say with the open community as they move outside of Autodesk now. So
Anthony is all yours. You have about 25, 30 people here.
Okay. Hi, folks. Thanks a lot for the time. Can everybody hear me okay?
yeah.
Yes.
Okay, okay, great. So I'll just reiterate, Ian sends his regrets at the conflict where he couldn't be here. And suffice it to say, as far as our backgrounds, if you've had a problem with Dynamo in the last 10 years, it's probably Ian's fault. If you've had a problem with Revit in the same period of time, it was probably my fault. So now we have a company. We can make problems together. The problem we're looking at is generative design. And one of the things that kind of came to our attention is that it's still a small club of people who are doing this, and an even smaller one who are actually applying it to practice. And so we started to think about how can we make this available to a wider audience. If you guys have not seen this book, The Future of the Professions, I highly recommend it. It crystallized a lot of our thinking around where we think the practices of architecture and engineering and construction for buildings are going. But this is kind of one of the key thoughts in there, that increasingly capable systems will transform the work of professionals, giving birth to new ways of sharing practical expertise. And let's talk about what we mean by practical expertise. So we've been building stuff for a long time. If the presentation is keeping up, you're seeing the oldest known construct that we recognize as a building from 3500 BCE. It's in Scotland. About 3,000 some odd years later, we actually started writing down what we think are good buildings. And then about 2,000 years after that, we took these inventions that happened along in the 20th century and tried to put them together with some of that expertise, and we started coming up with stuff like this. So this was a real computer program in 1970 that would produce hospital layouts from inputs that you can see on the left, like number of beds, area per bed, unit construction cost, etc. They're not very good floor plans, but it was 50 years ago that this was actually trying to be practically applied into practice. And then, so, you know, we get what, 5,000 years of building history, we get 2,000 years of writing about buildings, we get 50 years of computation, and it all comes together, and then we get this. So I thought this was pretty cool back in the 80s. I started using AutoCAD 2.6. I had been drafting by hand before that, and I thought this was great. This is about the time that everybody in the industry with more experience than me should have risen up with a howl of outrage to say that this entire history of building coupled with these magical machines had come down to a void with a locus of attention. Let there be lines. So what we had done is, you know, we had taken this and we turned it into this. But, you know, never fear. 15 years later, after a lot of effort, we get this. So I have a whole nother presentation where I talk about why stuff like this happens. There's the Western theory of art basically starts with a blank canvas, adds a genius, and gets a masterpiece. There's nothing that actually works that way. Picasso swore up and down that his paintings that happened right after he went to see a show of African art were not influenced at all. You can make your own judgments if you look through his history, but the point is, after 5,000 years of building, we're starting from a blank sheet, and we shouldn't need to. All our expertise is mostly still sitting here with these folks, and they're delivering that expertise at the rate of about 1 hour per hour, except for this guy. He's really killing it, and he delivers it at 1 hour per hour, and they scale by hiring lots of other people who also move at 1 hour per hour, and they find their expertise in places like this, and in places like this, and in the best case, at the moment, places like this. So, Ian and I started asking a few questions. So we wondered, you know, what if you could leverage open source and open standards, make tools that don't lock you into a single platform? And then if you're a building professional, what if instead of selling your time 1 hour per hour, you could sell your scalable expertise as a service instead? And what if you can generate the built environment to help all the project stakeholders make better decisions faster? And then finally, what if you could access this for a lower cost than what you spend on Netflix every month? So because, you know, when I'm starting a development project, I don't start like this. I don't start from this blank void and then, you know, type in some genius, because I have other things to help me out. I can type this, just 24 characters, and I suddenly have access to thousands of labor hours of other people's work who have encapsulated critical expertise. And if that's not enough, there are 15 additional frameworks that are built upon this that I can choose from to do a Node.js web project. So we looked at this in the software world, and there are literally thousands and hundreds of thousands of examples of toolkits that you can start off a project with that gather up the expertise of lots of people who know more than you before you start. And we wondered, why can't we do that in architecture? You know, why can't we do this? So if any of you went to Forge DevCon, you got to see Autodesk show this on stage. So from a site we're selecting here, we're just going to generate a whole bunch of tower options. Then we're going to go into one of them, and we're going to download it to Revit. And so we've got all these slabs and columns that have come in to Revit dimensionally correct. And now I can elaborate on this for the rest of my project. We know how to do these things. Like, we know how to put up towers, we know how to do step backs, we know where columns go. The problem is our delivery mechanism is somebody reads about this stuff in a book and then puts the stuff in the right place. What if we could do this? If you've been following some of my progress on LinkedIn, you've seen this stuff where we can pull in a building program and then hit the sample 20 options. And again, these aren't great, and I'm still making them better, but I got it in a couple of seconds, and I can get 20 more in a couple of seconds. And at some point, I'm going to hit something that feels good enough to elaborate on because it's close enough. And it's going to get closer as this develops further. Every one of these things on the site is an individual function. And you can see from these little icons here, these are actually GitHub avatar icons. And they're sourced from different parts. That upper left one is from a company called TestFit, which you guys may have heard of. We know the CEO pretty well, and several months ago, we sort of sweet-talked him into having one of his lead engineers break loose a piece of their desktop software, their shell generator, and put it up on HYPAR. It took him about a day and a half to break it loose from the rest of their desktop software. It took him half a day to put it up on HYPAR, and that's when putting stuff on HYPAR really sucked. It's a lot easier now. These ones with the little kind of black icons are things I wrote. The HyperDuct thing, that's Eric Rudisell from Microdesk there. He's governing that repository, but that's from the Beyond AEC Hackathon that a bunch of us did this past summer. And then we've got this other thing, the HYPAR starter project. But the thing I want to put before this group especially is this is an open platform. What if your firm could put something on here? And we'll talk about why you might want to do that in a moment, because we're not going to really stop at these kind of monolithic things. Where we're going next is the ability to combine several of these things into a complete option deliverable. So, something to select your site, something to generate a shell from offsets in that site with setbacks, something to take that, populate it with floors and columns, something to put all the spaces on each floor, and something to run duct to each of those spaces. So these are all atomic areas of expertise that you should be able to freely combine at a much higher level than you're working in visual programming environments today. And once we start getting these generators working together, we're also looking at what evaluators can we put in here. And, of course, we've been looking at things like Ladybug tools, and can we bring them on here to get linked in so that you can understand how these things are performing in various aspects. What about crowd simulators? What about, fill in your idea here. But one of the other things we're looking at is that we know there's an awful lot of expertise in the industry that's locked up in the primary engineering competition to every large AEC software provider, and that's Excel. And of course, Google Sheets. So the next place we're going is, can we get you to the point where you can just upload a spreadsheet and use that as an evaluator on your designs, like you're doing today by typing numbers into some spreadsheet that some guy's been working on for 10 years. And finally, we ask the question, well, if you're going to do all this and it's a benefit of your firm, that's great. What if you could expose it? What if you could charge other people to use it? There's no reason that you should share your expertise without compensation. So that is also something we want to support for folks who have proprietary expertise that they would still like to share as another revenue stream for their firm. Because right now, 1 hour per hour is how you make your money, and you're not making any money when you're asleep. And there's no reason you shouldn't. So the platform itself has a number of features. It's completely scalable computation. When you provide a function to it, you provide a function that makes one thing. We distribute it across multiple CPUs and exercise it, so nobody has to know anything about multiprocessing or multi-threading and learn all that stuff, because why should you? That's not your secret sauce. We can deploy the functions onto the site. We have a command line interface. We also have the capability to webhook into GitHub repositories to pull changes in to give you a full CI/CD pipeline, which is continuous integration and continuous deployment, for those of you not steeped in the jargon. We also provide you function interaction. There's an automatic UI that you get if you upload a function. We'll produce the options. We're coming up with the function combination next quarter, the input interfaces for your parameters, the results presentation, and the data interoperability that you've seen. That was a pre-release Revit service, but we can also supply a plugin to do that, and we're working on IFC. But all of this is kind of meaningless unless we have contributor functions on the site. We want to provide a forum where the industry can start displaying, scaling, and combining its expertise, because the one thing our industry is terrible at is building on our past successes. The software industry does this all the time by making toolkits available, and people build toolkits upon toolkits upon toolkits, which is why everything goes very fast. We're starting from blank sheets all the time, and that's why we're going so slow. If you're interested in looking at this, our data model is entirely open source and always will be. We have a motto: do not make anything that you can beg, borrow, steal, or buy. And it turned out there was nothing that was actually a good open source representation of building elements. We went to a few firms who we knew had them, and they said, no, that's our IP. And we said, okay, so we wrote one. We would be delighted if people would use this and extend it. HYPAR elements, it's up on GitHub. And if you want to get started with this, right now we're taking C# modules. There's a .NET starter function. It literally, after you download it and run a little utility that we supply, you will find a file that has your code here. And I personally haven't been programming until this year since about 15, 16 years before. And I upload to HYPAR like 20 times an hour when I'm updating the Office planner. So where's this going? We know a lot of folks aren't ever going to be able to code their own expertise into the environment. So we expect that either we'll consult, or other people will consult that we can recommend. Maybe some of you in the room. We know there's professional software developers out there who can take building information and turn it into something interesting. And for those of you in practice and in academia, we're really looking to you guys to see if is there something that you can expose even for your own firm, because deployment really is difficult, generally speaking, to the desktop, but we're trying to make it very easy to the web so that you can go through the platform and get a bunch of modules exposed that lots of people can use to do a bunch of things. So, why would you do this as somebody who's trying to make a profit in the AEC industry? So, most of our folks become most valuable on the day they retire. And I know one institutional owner where nothing moves if one particular person is on vacation, because she's the only one who has their standards wired. Capturing and scaling expertise is something that the whole profession should be looking at. Extending the firm reach, and I'll talk about what I mean by that in a moment. The ability to explore alternatives, to accelerate decisions, raise a client confidence because you've done the proper exploration through all the things they might come up with, like, what if we had 200 more parking spaces? And then finally, to capture latent demand. And, what do I mean by that? There's a lot of great projects that go up, and, guess what? You don't get picked for most of them, whoever you are. You will never contribute to this project if you don't get hired to work on this project, unless you have captured your expertise in some scalable way on the web so somebody else can use it even if you're not picked for the job. So then we asked the last question, what if your firm's expertise could contribute to any project, whether you're hired for it or not? Because I know for certain that all the projects you're not hired for are generating zero revenue for you. So the possibility exists, if you expose this externally, expose your expertise, that you can start realizing revenue from people who will never, ever hire you, because most people don't hire architects and they don't hire engineers, but they still need buildings, and a lot more as time goes on. So winding this up, and then if we have time, I'm happy to show you guys some stuff live. I'm going to go back to the future of the professions. Right now, the building professions are serving a very small economic stratum of society worldwide, and the choice for almost everybody is not between I'll get the really, really good architect, or I'll get the good engineer, or I'll get the kind of okay architect and engineer. It's I can't afford a professional, so I get nothing. That's an entire uncaptured market by the professions. We're hoping that we can provide an avenue so folks both in academia and the professions can start reaching out, contacting those people, and realizing revenue if they want it. And that's it. Does anyone want to see that I don't have anything up my sleeve? Because we can just go live here.
You guys want to see live demo? Yeah. Yeah, we have a few more minutes. If you want to show us something.
All right, I'll just go. This isn't ours. I'm just going to go into. I might have to log back in. Sorry. I'm going to go into test fits. Little function. So when you upload a function to HYPAR, there's a format for asking for a location input. And if you ask for a location input, we'll put up this map box thing, and you can start to go choose yourself a site. This particular function I know likes pretty big sites. So the moment you saw all the previews, we were done calculating all those options. It just takes a few seconds to generate the preview. Going into an individual one, you can get some information that the developer has exposed. There's the inputs. They decided not to show any outputs on this. And then we underlay this location view beneath the model at the right location for you. So we're going to be expanding the kind of inputs. In the video, you saw the CSV input. That's in this one. So, again, nothing up my sleeve. And go, and I can open that up so you can see what's in there. And this is a pretty straightforward program as Excel pulls itself together here. Nothing really dramatic in here, and except Excel doing stupid things with the delimiters to turn these into dates. Don't use Excel for CSV. You heard it here first. Anyway, so we'd be interested in hearing back as you guys think about this, like what kind of inputs would you want? What kind of things would you like to bring in? How would you like to do that? Because what we want to do is make this as falling off a log easy for everybody to be able to supply their function into the web rapidly and get exposure and get people using it and hopefully raise the quality of buildings thereby. And, just for grins, let's just do that. The thing we didn't see. How about that? There we go. So anyway, questions, comments, insults, diatribes?
Quick question, Anthony. You mentioned that you're targeting seasoned professionals to be able to scale their expertise in a codified fashion, and that that's part of the business model. can you expand on that? How would you do that?
Right. So we're actually doing, personally, we're doing a few things right now. We have a couple of jobs where we're talking to folks, especially the real estate people seem pretty excited about this kind of thing. So we're trying to kind of codify their rules to produce options in this regard. Our hope is that we will not have to do that forever. As we do each of these, we expect to be building up a kind of base series of modules that people can then recombine. But we're also hoping to marshal up the whole industry that actually knows how to do stuff like this and start using the platform to scale up the stuff they're already developing for external exposure or even just exposure through their whole firm. Because we have also seen a lot of firms that talk about how they find it difficult to deploy and maintain what the prototypes they've come up with, which are usually universally very cool. But since they're not software companies often, TT, Arup accepted, they find it difficult to devote all the time to build up a common technical stack that we're seeing over and over again. And, you know, 6 years ago, everybody did a Stadium Bowl configurator. Now it's a web viewer. And, you know, this is not something that everybody needs to burn cycles on. So we're trying to provide a bunch of essentially commodity technology figured out for you so that you can concentrate on getting your expertise down into code and not worry so much about how will the UI work, how will I scale up computation on the web, how will I handle login, all that kind of stuff that is just off the critical path.
Got it. You got a question for Anthony? It's this already available for public use?
Yeah. Yeah, this is exposed. The only thing we haven't exposed yet is the Revit download. If somebody really wants to do this, we're happy to provide the Revit add-in that will do it for you. It's just this demo we did off of the pre-release Forge Revit Automation API, which is itself not publicly available yet, and it's going into beta on January 28th. So we're hesitant to make that public, but to do that, we had to write a Revit add-in to bring stuff from HYPAR into Revit. So otherwise, you can download it as a JSON and play with it to your heart's content.
I'm checking online, and there's one more question. When will somebody pay to use HYPAR?
When we get the paywall in place, we hope. That's probably, that'll also be first quarter. We'll do that, and we'll set up the pipeline that if somebody wants to charge for the use of their function, that we can pay that person.
Cool. Mm-hmm. Yeah.
Hey, Anthony, in the first example that you showed with the Revit download, can you walk us through the inputs of how the form was generated, with the number of floors or the setback or the columns?
Yeah, this is like super simple. We actually did this one because we were meeting the next day with a land developer. So we're like, hey, we need some demo that shows somebody using a site. This is pretty straightforward. There's a few things going on in here. One, we're taking the site outline and then just offsetting it a set amount in this case. It's one of those things that we could put in as a variable, for example. What's generating the kind of range of stuff is the target area. So if I lock this down, you'll see it'll just turn into one option. So if I change this and say, well, I only want to hit, a particular square footage, it all of a sudden drops to like this option. We just have set heights at which we do a setback of a certain amount. And then there are 4 functions that we sort of shuffle up randomly, but we always migrate the retail, which is the green, down here. In fact, let me just wake up the usage. Thanks, so you can see what these things are. And we just kind of scramble them as blocks through the tower to show that we could mix up uses in some relatively sensible way. So the columns themselves that you were wondering about, that's just ranged around the perimeter with a few offsets. So all this is pretty straightforward, but it's not very smart. Of course, all the stuff I mentioned could start becoming sliders and inputs.
Right. And so are the inputs just one number, one certain number, or is it a range? And is there some sort of optimization that is tied to it or will be tied to it?
Right. There's no optimization yet. We've identified 3 types of functions we're going to have on HYPAR: the generators, which is all we have right now, and then evaluators, which basically tell you what the generators have produced, and then optimizers, which try to make them better. So right now, because we're relatively new and we're trying to obviously grab some attention, the generators seem to capture everybody's attention. So we've done a bunch of those. But next, we're probably looking at evaluators, and then once we have that, the optimizers is the obvious next step.
And one last question. If you get all of these senior, seasoned architects to give you all of the information that is needed for, let's say, developing a hospital versus a mall, then if you have the database in HYPAR, how do you see their job? Why would anybody need an architect anymore?
So a couple things. One, we will not exactly have a database, I think, in the same way that you're thinking of it. We might have a bunch of options stored, but for example, the code to make this stuff, that gets compiled on your desktop and we never see it. So all we get is the functioning DLL. Why does anybody hire an architect? Really for the same reason that they hire architects now, because they actually need to define the problem, not necessarily just get a cookie cutter answer. Because, there's a lot of cookie cutter buildings going up that architects aren't involved in. I think that trade is already lost, unless their expertise is exposed in some manner that those people find it attractive to use an architect's expertise again in a different way.
Any other question? Well, this is awesome, Anthony. Thanks for giving us a sneak peek of the product you're working on. I trust we will have a chance to host you again sometime at the end of next year to show the next interaction of HYPAR. You're always welcome. And this is going to get recorded and posted in our website, so stay tuned for the recording after this meeting. Now we're going to go ahead and introduce our second speaker.
Thanks a lot, Anthony. Nice evening.
Thanks, folks.
Thank you. All right.
Okay, our next speaker is from Italy. It's Andrea Zani. He has done his PhD between Politecnico of Milan and University of Berkeley, here around the corner. So we're really flattered to have him here, and he's going to talk about computational approach for the assessment of the effect of solar radiation on indoor comfort analysis. So thanks and welcome, Andrea.
Thank you. Hi, everyone. Can I go on the other side?
Yeah, sure.
Thank you. So today I'm going to present this research study that I developed with Professor Keough and Arends from UC Berkeley and some colleagues from Milan. And it's a new way to calculate the impact of solar radiation on human comfort. So a brief introduction. solar radiation passing through the windows, if it's not properly controlled, can have a significant impact on comfort, and can be visual comfort. It can generate high luminance on your working plane or visual glare that impacts your productivity, for example. But also we have thermal discomfort. When the radiation passing through a window, there is a raise of temperature that our HVAC system has to offset. And what we are talking about today, when the sun strikes on your body, your temperature increases so much that it's going beyond the HVAC system capacity. So also if the HVAC system is set to 20 degrees air temperature, you're not going to be in a comfort condition. You're going to be super hot. And so, for example, this guy here is not, probably it's fine. It doesn't have glare because the line of the eye is in shadow, but the rest of the body is completely exposed to the sun. And this guy is going to deploy probably the shading and not see outside anymore. And the other folks around him that are in comfort, they don't have any more daylight. So if we don't take on these problems, we have a huge impact on the performance of oh, to show you the screen first. So
sorry guys online.
Sorry. So we have a huge impact on energy, performance of the building, and also comfort for the user inside. And for example, in this example, all the users close to the facade has to deploy the shading because they're so hot that they cannot enjoy the desk near the facade, but not just for a couple of hours during the day, but being exposed on the south, they have to deploy the shade basically all day. They're not going to see outside basically never. And in the other building that is here in San Francisco, the entire first row of desks are unused because it's too hot close to the facade. So it's a huge decrement in the amount of space that this tenant can use. So it's really significant. So fortunately, last year came out this standard, it's ASHRAE 55. So we have at least a method to assess the influence of solar radiation that hits the human body. Before then, we didn't have any standard. So many buildings encountered this problem because there was no procedure to evaluate. So now we have this ASHRAE, and we have several methods. Here's a bunch of formulas that define how to calculate the amount of increment in temperature on your body. And these formulas we are going to see later in the script. And here, the last step, where we convert this effective radiant field that measure the incoming and outcoming radiation and transforming temperature. The standard defines a series of steps. Step one is to calculate the long wave mean radiant temperature, that is the radiant temperature generated by walls, floor, desks, or irradiates when they are warm. And second step, we have to assess the short wave mean radiant temperature, that is the amount of increment of temperature generated directly from the sun hitting the user. And third step, we have just to sum these two to have the total amount. So right now, we have this super useful tool developed by CBE, where we can input a series of parameters like for example, solar altitude, the amount of solar radiation that is emitting from the sky, the direct solar transmittance of our wind of blast shielding system, and other like fraction of the body exposed to the sun. We inputted all this data, we click calculate, and we have the mean radiant temperature delta, that is the short wave, and this number. Great, works really well. And then you can say also to us, oh, look, you are compliant, you're not compliant anymore because your radiation that is in your body is shifting the comfort zone, so we're not anymore compliant to the regulation. So great tool, especially in the first stage of the design, but there are several limitations. For example, is manual input. You have to input manually how much radiation you have from the sun, how much body is exposed to the sun. Is point in time, so if you have to investigate several hours and several days, you have to redo every time all the steps, and it's super difficult to assess these parameters, the solar transmittance, the amount of fraction of the body exposed to the direct sun when we have a complex scene. For example, with desk, the monitor, the shading system outside. So it becomes a little bit challenging for the designer to input the right number. So the objective was to try to solve all these limitations using a computational design approach, in particular using Radiance, Energy Plus, and combining all together with tools like Honeybee, Ladybug, and Python. So this is our simulation workflow. We start with rhinoceros and grasshopper to generate the scene. So for example, this room, and a mannequin that is going to simulate our body. And the body is split in 363 points to have a really good map of the human body. And then we use Radiance, that is the most used tool to assess the lighting. But with some trick in the script, you can calculate and obtain radiation instead in luminance or luminance value. So we have the mannequin, we have our sensor points, we have Radiance script, and we can calculate the amount of radiation striking on the body, and we'll see later where did the sun hit the body. So like each patch is going to give us the number, a number that represents the area exposed. This is the translation in Grasshopper. So we have our scene, we create a scene, mannequin and sensor. So we generate the mannequin and number of points and sensor direction. This is the Radiance part. So we're going to see what is inside here. And then here, the formulas that I showed you before are implemented in simple components of Grasshopper, and then we can visualize the results. This one is a typical script from Radiance. So you generate the sky for each hour of the year, and then here basically we split the direct radiation and the diffuse radiation. So splitting the direct and the diffuse, we can use the portion of the direct to calculate which part of the body is exposed to the radiation, and then we combine everything together. In this part here, we calculate the radiation instead the luminance, and we have the output. And here, the formulas that I showed before, just implemented in Grasshopper to calculate the delta MRT or short wave MRT and ERF. And on the other side, we have Energy Plus simulation that helps us to calculate the general MRT. And this is quite more messy script because we have to calculate the temperature based on where is the person compared to the walls. So we have to calculate the view factor compared to the specific surface. It's kind of messy, but at the end it's pretty accurate. And then we can calculate other stuff, like for example PMV, that give us an idea if the person is in comfort or not. This is our test study. So simple single office, and we have the mannequin in different position compared to the window. And first step, we validate our method. So we compared the solar car method implemented in the web tool with our script in Radiance first, and then we rewrote basically everything in Honeybee to have the same kind of workflow in computational design mode. And the accuracy is pretty good. And we assess for different sky condition and different time during the year. And here is basically like a typical output. Instead of having like a single output for the specific hour or the day, we can have this graph that can say for how long our occupants are in comfort or not. And here, like for example, this is our baseline. If we don't consider the effect of solar radiation between 0 and 1 and 0 and -1, we are quite comfortable in the PMV range. But if we consider solar radiation, we are almost all the time not in comfort. So it's a huge impact on the design. And we can evaluate different conditions, for example, overhang or different kind of glass. And these data are annual data. So in here, there are all the hours during the year between 8 p.m. to 6 p.m. And we can plot this kind of visualization. So we can have basically over 5 MRT delta, we are in potential uncomfortable zone. So we can see, like for example, with the baseline, we are basically uncomfortable all the year, all day. As you see in the example before, you have to deploy the shading. If we introduce like a louvers outside, we can decrease the amount of hours that are uncomfortable for our occupant. And we can plot and extract data for a typical day. This one, for example, is an extreme day of the year, and compare different sound transmitters of the glass and see if our occupant is in comfort or not. So what are the new outputs and capabilities of our workflow? We can simulate complex scene, so we can take in account the effect of a desk, a monitor, chairs, whatever you want. Everything is automatic. You don't have to input anymore every single value. Calculate view factors, amount of radiation, and you have annual results, hourly annual results. For example, like this one. And on the other side, you have a detailed human body radiation map. So you can see where the radiation is landing on the occupant and define a strategy to decrease, for example, the amount of radiation that hits the head or the hands that are more sensitive to the radiation. So we have a good accuracy with the HyparAEC method. We have short calculation time for this specific condition, so 363 sensor points. We can use this tool to assess the performance of different facade systems, and of course can be valuable because we can assessing and changing design of our facade, we can reduce the amount of uncomfortable hour during the year. But what are we missing here? We just step back and say, oh, okay, but now we are assessing single position. If we have only one mannequin in this room, how can we assess the entire space? Because in the preliminary stage of the design, you have to investigate maybe several facade configuration for the entire space, not for a single position. You need something to assess how works everything. So a new framework for preliminary analysis to define how the space behaves, comfortable or not comfortable, and consider overall and local thermal sensation. Right now, we're not considering that the head, for example, is more sensitive than your back. When the radiation hits your face, you are extremely warm compared to the radiation that hits your back. So how can we achieve this goal? Defining a spatial analysis and a new metric to understand how space perform. And the second one that I'm not going to present today because we are going to develop next year, it's a machine learning algorithm to implement the different sensation of the different parts of the body. So we're going to train a machine learning algorithm to understand and tell us the different influence of each part of the body. So what we did is say, okay, we have one mannequin, let's spread around and create like a grid with all the mannequins. Okay, 330 sensor points times, for example, for this case study, 150 position. We have 54,000 calculation points. It takes forever with a normal machine, of course. So what we did is like, okay, let's try to simplify our mannequin. So going to something less precise, less accurate, but that can give us a good feedback on amount of radiation that's striking the body. So at the end, the minimum amount of points that you need for good accuracy is like around 30 points. And as you can see here, we still have a good accuracy over the year. What we notice is that if you increase the density of your shading system outside, you need more points. So based on your scene that you're going to evaluate, you have to use one of these mannequin, increasing or decreasing the calculation time. This is the script. We have integrated also a part to assess the daylighting. So using the same grid, you can automatically calculate daylighting performance and thermal comfort performance. Okay, we're ready. What happened? We ran the simulation. Nothing happened. Completely stuck everything. And Grasshopper cannot handle all this data. We should have like a multiprocessor Grasshopper probably, but it's completely stuck. I tried one time and like for an hour and a half. Why? Because also with 29 points, we have total amount of sensor are 4,350, 29 times 150 times 8,760 hours for the year. So the matrix is this amount of data, crazy big, and Grasshopper cannot handle. So Python is helping us right now. So what we have done, thanks to Harry, a great talk from Microwatt and Alberto, we wrote this Python script to basically solve the limitation that we encounter with the Grasshopper script. So what it's doing, we set all parameters is going to read the output file of Radiance, and then read how many mannequins you have in your room, and here, and this basically writes how many sensor points and mannequins you have in the space. And here, really important, we set a threshold that's going to say, oh, if your MRT is greater than 4, you're going to be uncomfortable, because you're going to step out the comfort zone. And finally, we calculate for each mannequin, for each hour, all the parameters that I mentioned you before. And at the end, in this area, we have defined the new metric we call annual radiation discomfort metric, and basically count the amount of hours that you are over the threshold of 4 degrees. And it's able to plot the results in a color map visualization and box plot that's telling you near the facade what is your medium and minimum upper value. And for example, here is a couple of examples. This is like a baseline with a low E glass. So basically, for the first 2 meters, your space is going to be uncomfortable for 40% of the time. So basically, all this area you cannot use unless you deploy the shading. But if you change the glass with a high-performance solid control glass, you have a space that's uncomfortable in the first couple of first meter. But if you implement better glass with some shading system, you can decrease even more. So basically, the entire space is usable. So in conclusion, we have created a new framework that can help designers to take in account also thermal comfort in the design goal, and couple the design comfort with daylighting, because the grid is exactly the same that's used for daylighting. So you can compare and see, oh, we have a spatial daylight autonomy of 90 and RD really bad, so we have to change something. So we define a metric that can help the designers, and we increase the interoperability, because before you have to run Energy Plus simulation and then Radiance simulation, combine the data. Now you have the Grasshopper script that can handle everything. Just if you input your scene and your grid size, automatically generate all the mannequins and simplify the geometry for the Energy Plus simulation. And then the Python script, you just change the name of the output file and automatically give you the answer. And we will try to create a Grasshopper script, Python script, so you don't even have to open Spider or whatever to run the Grasshopper script. And we are still working on some stuff, how to implement bidirectional scattering tools from function that are methods to assess really complex penetration system. We are working on the Grasshopper Python script, and finally next year we are going to work on the machine learning techniques to assess the local thermal sensation. And here all the people that work with me on this project. Thank you so much.
Is this a project university research, or is it commissioned by somebody, or?
Entirely university project, so it's not funded by anyone, just for fun.
And is your goal to make a package for Grasshopper or something?
Yeah, probably like a Hydra file or some components that we're going to implement probably with Mustafa, Ladybug, and Onibi. So probably we're going to do something with them too. Yeah.
Do you have
completely free?
Do you have a animal name for?
No, but I will think about one possible name.
It's called a Comfort Eagle.
Nice. You have the copyright.
So I have a question. First, when you, it's probably when you work in Grasshopper, it's a single-threaded. So even if you have the, multi-processor, you can use only one core for it.
Yeah.
Did you, when you wrote the Python script, did you still living within the Grasshopper, or you moved to Rhino script, or outside the Rhino environment?
Was outside the Rhino environment. Yeah. For
and
now,
it was
yeah.
multi-threaded to Rhino.
Yes. And basically, what we have done, the script was reading one line each time, and then grouped together like 29, because the mannequin is 29 sensor points, so it's going to read one line at a time, and then merge together 29 and speed up output, and then merge all together. So one sensor point at the time for the entire year, merge 29, and then again and again and again.
Will your final product have like location data, data input, like very different from the coast and the East Coast, like just temperature-wise?
Yeah, you have basically when you run the Radiance script, you have you input the weather file, so it's going to calculate the output based on the location of your project. It exactly works as like an energy blast simulation. It's the same input file, and the Radiance generates like a sky matrix using the input data from the APW file. So yeah, you can use it wherever you want.
Have you guys also tried using like
Sorry?
Have you heard about Clear as Windows? Like it's really expensive right now, but have you?
No, you can.
They're NASA's using it the administration. You can see through it, but it's also like bulletproof, and you can't get solar radiation through it.
Okay.
Yeah, curious if you heard about it.
No, not yet. But yeah, with this phase here, where we're going to investigate several materials, we have in mind to test as much as possible. So we're going to test probably also this kind of material.
I want to know, I didn't see how emissivity was involved with your calculation and how like glass emissivity might impact your calculation, but also the localized air temperature due to like air distribution or air movement in some of these questions that verge into CFD territory. Just curious if there's any plans for that in the longer term, and then also have you ever been heard of UTCI or Universal Thermal Comfort Index? Is it an exterior metric?
Yeah.
I've, for lack of an interior metric, applied that in projects.
Yeah. I start with the last one about UTCI. I think that could be used too, because when you have solar radiation on your body, the PMV is not the best way to assess the comfort, because if you look at the box plot, we had some points over the threshold that is 3, so off the scale, because it's not really accurate when you have radiation. So yeah, you can translate the script to assess, for example, UTCI. And about the CFD, right now it's not taking into account local condition like air movement and local air temperature based on, for example, this airspace that you have close by, but just on general HVAC system that keep your temperature in the range. But it's taking into account the portion of the radiation from, for example, hot surface close by. Yeah. So yeah, I think that in the chunk of research that implements like machine learning, so like more accurate and thermal sensation, it's important to merge also with the CFD, because you have to merge like radiation and airflow together. And the thing that when you have the radiation on your body, your temperature rises so much that you can forget something. It's like it's so warm that also if you have like a cool hair, it's not that important. But yeah.
Yeah, I mean, but so like if you do these in Hawaii, for example, they're very used to like a warm environment, but they have a lot of open natural ventilation because they have much higher airflow, and so that they're more comfortable with that. And
yeah. Right now it's only like PMV, but as you know, you can use like adaptive comfort. So you have to change the range. And right now, this matrix is only static about PMV. Yeah.
And this is only simulating, I guess, with a facade, not taking consideration to the environment. For example, if you're planting a tree,
you can. Right now, we tested facade because I'm a facade engineer, so I like facade in general. But no, it's able to take into account any obstruction. For example, the desk, you can have the tree outside. And you can, thanks to Honeybee and stuff, you can, for example, change the transparency of the tree, so you can see over the year with the amount of leaves that you have in the tree. So you can control also the these kind of parameters. And of course, if you have a building in front of you, no problem.
Cool. Well, let's give Andrea a big applause. And for inviting me. He's now part of our committee as well. Look forward to working with you another year.
Thank you so much.
And then as a final act, if you would just want to hang out and check the AR labels provided by Tactic. Hannah is here. She is with Tactic. She could do a demo of the of how they worked. It's pretty cool what these guys are doing. Basically, augmented apps that enable animations on wine labels. You guys use Unity?
Okay.
Yeah. So wine's there, food is there. I don't see any question on the line, so thank you guys on the line. I expect this recording shortly, and we'll see you in January. All right. Happy New Year, everybody.